Hi, and welcome to our 21st test and measurement video on today's amazing oscilloscopes. We'll talk about the triggering capability of the Tektronix MDO3104. Associated with it is an elaborate set of menus permitting the operator to set parameters in accordance with the project objectives. At the start of the huge post-World War II electronics boom, Howard Vollum and Tektronix co-founders developed a triggered sweep oscilloscope derived from radar technology that at last permitted the oscilloscope to display a stable waveform based on an analog input. Previously, only single acquisition displays were practical. Others, as they cycled, would not precisely coincide at the start of the timeline. The result was a rolling, flickering trace that made it difficult in the extreme to extract useful information. The problem was resolved by the simple expedient of initiating successive traces at the same point in each recurring set of waveforms. Precisely superimposed one upon another, a single image of the trace would be created so as to make a readable display. The procedure can be likened to a camera shutter opening at exactly the right instant. Triggering is an apt name for this process because the shutter, so to speak, opens at a specific event in the life of the waveform so that there is a uniform, stable display on the screen. To see how this works in the real world, we've connected a BNC cable to the AFG output on the oscilloscope rear panel and hooked the other end of the cable to an analog channel input at the front. Then, after the instrument is booted up, press AFG, the bottom button, in the vertical column to the left of the Channel 1 controls. The first soft key on the left below the display brings up the waveform menu. Sine is default. That is a good waveform for this demonstration, as you can use multipurpose knob A to select another one, such as ramp. We'll close out the excess menus for clarity and look at the ramp wave. In the column of trigger controls just to the left of the keypad, press the trigger menu button. Notice the horizontal bar at the top. The icon labeled T shows the location of the trigger point. As you turn the level knob in the triggering section, the trigger point changes with respect to the Y or amplitude axis. You can move it from 0 into either positive or negative territory. To reflect this, the waveforms slide horizontally but do not move vertically. The really interesting thing to note is what happens when you move the triggering level above or below the most positive or negative amplitude level of the signal as displayed. Triggering ceases and the waveform is no longer stable, as in the pre-World War II instrument. Triggering is reinstated when the triggering level is returned to any position between the signal's positive and negative peaks. Returning to the triggering menus, press the soft key that corresponds to triggering type. The choices are edge, sequence, pulse width, timeout, runt, logic, setup, and hold, and rise-fall time. Edge triggering is the most basic type of triggering. It takes place when the trigger source reaches a given voltage level, moving in a specific direction. It can occur on the rising edge, falling edge, or both edges. Use the slope control to define it. In this particular mode, coupling may be by DC, low-frequency reject, high-frequency reject, or noise reject. The sequence trigger type permits the operator to continue a main event with a delayed event to display a complex signal. Pulse width triggering, and in conjunction with digital signals, permits the operator to trigger on pulses less than, greater than, equal to, or not equal to a time interval that you can specify. Timeout triggers when the signal remains above or below a specified value for a specified amount of time. Runt triggers on a signal that crosses one level but does not cross another level before passing back through the initial threshold. Source, of course, is self-explanatory. Thanks for watching. Next time we'll continue the discussion of triggering with some more advanced topics, including slope triggering and hold-off.